Hi everyone, now we're going to begin the review for test 2. So here's the first question. It says the radar antenna rotates at a constant rate if it's initially directed at 115 degrees and after 3.6 seconds is directed at 310 degrees. Find its angular velocity in A degrees per second and in B in revolutions per minute. So go ahead and pause, try to solve this one, and when you're ready, unpause. So let's write down what's given. There's a 115 degrees, which is an angle, and you have 3.6 seconds, so that's time, and you have 310 degrees, which is another angle, and we want to get the angular velocity in radians per seconds and in RPMs. So if you just draw a picture for what's happening, this is the antenna is rotating around, and when you first see the antenna, it's around 115 degrees around here, and then when you see the antenna again, it rotates so that's around 310 degrees in this direction. And so the 115, that's going to be the initial angle, and the 310 is going to be the final angle, and t corresponds to the total time between those two angles there. So the equation that we're going to use is angular velocity is equal to final angle minus initial angle divided by the time. So for A, we can just plug in as is. So the angular velocity is going to be the final angle, which is 310, minus the initial angle, which is 115, and then divided by the time, which is going to be 3.6, and that's going to give you 54.2 degrees per second. So that's the answer for part A. For part B, we just need to convert degrees per second into RPMs. So we have 54.2 degrees over seconds. So for us to convert degrees, so degrees is on top, so put degrees on the bottom to cancel. And we're going to go from degrees to revolutions. And the conversion is 1 revolution is 360 degrees. So then we'll put 1 next to rev and 360 next to degrees. And the other conversion, we have to convert time. So seconds is on the bottom, so put seconds on the top and then cancel. And we're going to go from seconds to minutes. And 1 minute is 60 seconds. So calculating that, that should come out to be, let's see here, 54.2 times 60 over 360, and that will give you 9.1 revolutions per minute. Alright, so now let's try the next one. It says a sonography transducer draws power to create medical images of internal organs. If the transducer draws 15,000 joules in 0.27 seconds, calculate the power in watts to operate the device. So go ahead and pause, try to solve this, and when you're ready, unpause. So let's try to solve this one. The first number that's given is a 15,000 J or joules, so that's energy, and 0.27 seconds, so that's a time. And we're trying to get the power. So the basic idea is that you have some kind of a device, and it takes some energy to run the device. Well, actually, I'll say it this way, is that to run this device for 0.27 seconds, you have to supply a certain amount of energy, and it takes 15,000 joules, or this is going to be the work that it takes to operate the device. So energy or work. So I'm just going to replace that with the work that it takes to run the device. And so the power is going to be defined as just the work that it requires, or the energy that it requires to run the device, divided by how much time you ran the device. So that's just going to be the 15,000 divided by 0.27, and that will give you about 55, well, there's a decimal first, so 55,556 watts, or about 56 kilowatts.